Let's talk about 1.5, the piecewise functions. First thing, let's think about graphing our piecewise functions. There are four things to think about when we graph our piecewise functions. The first thing is the critical points. Second is the use of an open dot or a closed dot. Open meaning it doesn't equal that, so open means it's greater than or less than, and a close is a greater than equal to or less than equal to. Third is you want to pick other points that satisfy the restriction. So points that satisfy restriction. And then fourth, but not last, connect the dots or connect all the critical points. Let's do an example here. If I were to say, this first graph, f of x equals x plus 6 when x is less than or greater to negative 4, and 2x plus 4 when x is greater than negative 4. First things first, let's look at our critical points. These here are critical points. And this here is going to be our line or our function. It doesn't necessarily have to be a line. It could just be a curve, depending on whatever it is that we're working with. Okay, so first line, x plus 6. So we want negative 4. It equals to or is less than or equal to negative 4. So I'm going to go back to negative 4. 1, 2, 3, 4. If I plug that into our equation, that is 2, negative 4. I'm going to do a closed circle first because it is less than or equal to. And then from there, less than that, it is x plus 4. That is a line with a slope of positive 1. So I know it should always go up. So it should look like that. Next part, when x is greater than negative 4. So if I plug in negative 4 to the second part of this graph, let me move this down just a little bit. Hopefully this works. Okay, so the second part here, if I plug in negative 4 times 2, that's what, negative 8. Negative 8 plus 4, that gives us what, negative 4. So negative 4, negative 4. So 1, 2, 3, 4. I'm going to do an open circle because it does not include it. I know the slope is 2, so it rises 2, goes over 1, rises 2, up 1. So the rest of the graph kind of looks like this. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And so we can put arrows at the end since they are lines. So this is what our first graph looks like. Let's try another example here. Moving over. Our example will be if f of x equals x plus 3, x is less than or equal to 0, 3 between 0 less than x less than or equal to 2, and 2x minus 1, and x is greater than 2. So we are dealing with uh, pretty much three lines. So let's start at the first one. The first one is less than or equal to 0. So I'm going to start with a closed circle at 0. If I plugged in at 0, we get the value 0, 3. So 0, 3 is where we'll start with a closed circle. I know that the slope, once again, is positive 1. So before, in the back, since it's less than, anything in the left hand should have a positive 1 slope. And I'm going to just draw a line with a positive 1 slope, like so. I know between 0 and 2, it's first a open circle, and then open dot, and then a closed dot. At 0, it will be 3. So there we already have a closed dot. We don't have to put in another one, but between 0 and 2, so at x equals 2, it should equal 3. 3. That is a equal to, so it will be another closed dot. I'm just going to draw a horizontal line like so. Finally, when 2 is greater, it's 2x minus 1. If I plug in 2, that is what, 4 minus 1, that gives us 3 at 2. Once again, that is our value. Our line has a slope of 2, so it's up 2 over 1. So the second part is just going to be a steep slope like so. Finally, last example here. Let's go down, and let's say our equation is f of x equals, let's try a different type of 3 plus x when x is less than 0, and x squared plus 1 when x is greater than or equal to 0. Notice the x squared plus 1, we are dealing with a parabola, and the 3 plus x, this is a line. So this is a line, and this is a parabola. Both of them will work. So when x is less than 0, so once again, we are dealing with an open circle at 0. So we plugged in 0, that's 0, comma 3. Starting off with the open circle this time. And the slope, once again, is a positive 1. So I'm just gonna go back with a positive 1 slope, like so here. Next part is an x squared plus 1. Well, let's look what it is at 0. 0 here, it gives us that it has to be 1. So at 0, y must equal 1. So this is a closed slope. Since this is a parabola, we have to consider the important critical points. Most importantly, the vertex. I know that x squared plus 1 is a regular parabola that's just moved up one spot. So I know the vertex is actually at 0, comma 1. So I know the next part should look like a normal parabola going up just like so. If you don't remember how to find the vertex also, or need a little review, remember x squared, this starts at the origin, where 0, 0 would be the basic vertex. If you add anything on the outside of our x's, so we did an x squared plus 2. I know this is a basic parabola going up 2 spaces. If we added onto the inside with the x, like in a parentheses, let's say x minus 2 squared, that parabola is actually a parabola that moves to the right 2 spaces. Counterintuitive in this point, but that is a little review of our parabola.